Hey guys, it's Mr. Thibodeau, just coming at you with lesson 57. So, new concept, probability. There are many situations whose future outcomes are uncertain. We just don't know. For example, the weather forecast might say that rain is likely tomorrow, but this is just a guess, right? An educated guess, but a guess. It might rain, it might not. If we take an airplane flight, we might arrive early, we might be late. There's a lot of things we just can't know. But there are ways to try and mitigate that and kind of come up with an idea of, well, it's slightly more likely for this to happen than to this to happen, right? If I flip a coin, it's basically 50-50. I'm either going to get, one side or I'm going to get the other side. Very possibly it lands perfectly like this, but it's such a small chance that we don't even count it in a lot of our possibilities, right? So, that's a 50-50, yeah, one or the other, right? If I'm looking at a deck of cards and I'm like, what is the chances that when I flip this over, the card on top is going to be a face card? Okay, well, there's 52 cards in the deck. Each suit, there's 4 suits. Each suit has a jack, a queen, and a king. Okay, those are 3. So that's 3 times 4 is 12, because there's 4 suits. So 12 of the 52 cards in here are going to be a face card. So 12 over 52, except we can reduce that and say 6 over 36, or 3 over 16. So 3 to 16ths. 3 16ths is the possibility that this is a face card. It is not. It's a 3. Okay, so it's pretty unlikely, but it's possible that that was going to be a face card, right? Probability is really interesting because, one, in realistic life, that's very unlikely that things are going to be a pure probability, whereas games, they're almost always pure probability. Right? So if I am driving my car, what's the likelihood on getting into an accident? Well, that's not either I am going to get into an accident or not, right? There's so many more things that are playing into that. Am I paying attention? Do I have my phone out? Am I an attentive driver? Do I have a really safe car that alerts me if someone's about to hit me or I'm about to hit someone else? Okay, so in video games and in card games and all sorts of games, there's really a lot of what's called pure probability like this. So these are actually really helpful to help us win at video games or win at card games, is to know the likelihood something's going to happen. Okay, specifically, knowing probability can be called counting cards, which is a style of keeping track of the probability that you're going to draw a face card when you, nope, still not. And that probability can be used to decide whether or not to bet or not to bet if you're at Vegas and you're trying to play some games. Okay. We also talk about chance to describe likelihood. So chance and probability are often used interchangeably. Okay. Okay. It does a decent job of talking about this. If you have a d6, a 6-sided dice, and you roll, what's the chance that the cube will stop with 3 dots on top? So number 3, well, it's 1 in 6, right? You have 6 sides. It's got to be on one side. Assuming the dice is actually weighted correctly, it's 1 in 6. Okay. Dot with more than 2. Okay, so the only time that it would not, so a 3, a 4, a 5, and a 6. So that is 4 out of the 6 options, right? So 4 of the 6 options would be your chance. The cube will stop with fewer than 7. Well, that's 6 out of 6. Okay, that's every single option is going to be fewer than 7. It'll never have 7 or more. Okay. Cube will stop with more than 6 dots on the top. That is a 0 out of 6. It's never going to happen. Okay, 6 is your upper limit. There are 6 faces size and only one has a 3 dot. We'd expect the cube to stop with 3 dots on top less than half the time the cube is rolled. Right? So it's unlikely. So that would be a 1 in 6 times, which is, of course, a smaller number than 1/2. 1/2 and 3/6 are the same. These are equivalent fractions. All right. I really like probability because I play a lot of probability games. Although I try not to base my strategy on luck, because luck is a cruel mistress. Here we have a spinner, so divided in 5 equal sides. So you spin it. What is the likelihood you're going to get something? Okay, assuming they're all equal, A, B, and C, right? That's 3 out of 5 options. Okay. So remember, the bottom number is your total, the total different options, and 3 is the ones you're trying to get, so trying for. If you are, this fraction here only works if they're both equally likely, right? If I drive my car and it's like, what's the likelihood I'm going to crash, right? There are 2 options, right? I crash or I don't crash, okay? However, it is not true to say that it's 1/2, 1/2. Either I don't crash versus I do, versus my total options, okay? Because these are not equal. I'm actually a pretty good driver. So if I was to add up all of the things in my favor, it would just be a very, very, very small sliver of likelihood that I crash, okay? Because I'm a very good driver, I have a good car, I'm really attentive, okay? Those are all things. I've never been in a car accident like that before, especially while driving. Those are all things that are in my favor, right? So it's not an instance of 1/2, okay? So not all probabilities are equal in that way. The good news is all the probabilities that you need to do math for in here are going to be pretty equal, okay? I think this does a reasonably good job of looking at this. Ben spun his spinner 60 times and recorded the outcome, okay? So, what is the likelihood? So, which one is he more likely? He gets 1 and 2 far more than he gets number 3, okay? So if it was an equal chance, we would expect these numbers to be like 30, 30, or 30. Now, the actual likelihood that they would, in fact, be 30, 30, 30 perfectly is very low, actually. But we'd expect them to be pretty similar. So it would be like 28, 29, 32, or 33, I guess. We'd expect it to be pretty close to that 30-30 mark. Just because the statistics tells you that it's an equal chance doesn't mean you're going to get it. If I flip this coin 10 times, what's the likelihood I'm going to get 5 times on here and 5 times on here, right? It's an equal chance each time I flip it. But likelihood is while it's going to be close to 50-50, it's never going to be exact when you do it in practice, okay? Usually if you get a large enough sample size, you get closer and closer to the actual probability of something. Probability in theory is great. Probability in practice is way more complicated. But looking at these numbers, 1 hit way more than 2, and 2 hit way more than 3. So this tells me if he was doing B and he got these numbers, he was crazy lucky or crazy unlucky. I don't know. And it would be insane. It would be very, 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 very unlikely that he did it on A and just never, ever, in 60 attempts, got that 4. That would be weird. Okay? It is possible that he did it on C, okay, and it's just a fluke of luck, okay? But most likely, your answer would be D, where he got 1 a lot of times, about half the times. Oh, I said 60, 30, 30, 30. That's for 90, not 60. Sorry, 20, 20, 20. D is the most likely choice, right? Because 1 takes up about half of it, so you almost got half. Okay, that one makes the most sense. Let's see. I think the book does a decent job. I'm going to go over all of this lesson practice with you if you stick around and you want the help. If not, feel free to do it without me. Let's do 11 through 25 odd for your written practice. 11 through 25 odd. Okay. All right, so go ahead and get the work done. Give this a shot. If you get stuck, just come right back here and I'll be going through it. All right, so what are all the possible outcomes? So there's 5 numbers here. So there's 5 outcomes. Okay. What is the probability that it'll stop on 3? Well, assuming these are all perfectly equal, right, it is 1 out of 5 because spinner 3 is just one of my 5 options. Okay. It's not 3 out of 5 because the number 3, that actually has nothing to do with it. Okay. Each one of these pieces has a 1/5 chance of being rolled. What is the probability of spinning a number greater than 3? So there's only 2 numbers bigger than 3, right? There's a 4 and there's a 5. So that would be a 2/5. Probability of spinning an even number. Well, how many even numbers are there? There's 1 and there's 2. So that would be 2/5. If the weather forecast states that the chance of rain is 40%, is it more likely to rain or not at all? No, it's less likely to not rain. Okay, there's a 60% chance of it not raining. Assuming, technically, this doesn't give me enough information, right? Because there's not just the option of rain or not rain. There's the option of snow. There's the option of hail. There's the option of freezing rain, okay? All of those are technically options. I don't know all of the stuff, but I do know that if it's only a 40% chance to rain, the likelihood of it being snow, hail, freezing rain, or just not raining at all of those have to add up to 60, okay? So rain alone is 40, and everything else, every other option is 60, okay? It will add up to 60, okay? If today's chance of rain is 20%, then what is the chance that it will not rain today? Okay, and it doesn't matter, you know, freezing rain, snow, all those things are still not rain, so it would be 80%. I guess you can make an argument freezing rain is still rain, but what is the chance that it will not rain today? 80% chance that it's not rain. Okay, for the experiment described in example 3. Okay, let's go back and read example 3. Which one's this? A bag contains 5 red marbles, 3 blue, 2 yellow marbles. Suppose we pick 1 marble out of the bag without looking. Which one's it going to be? So, total answers here, 5, 6, 7, 8, 9, 10. So a total of 10. And my blue marbles are 3, so it'd be 3 out of 10. Marble is not blue would be 7 out of 10. Probability that we picked a blue marble is a fraction between 0 and 1. Okay? All probability is fraction between 0 and 1. Okay, you can't have a probability that's greater than 1. This fraction describes the number of blue marbles as a part of the overall group. There are 10 marbles, so there are 10 possible outcomes. Okay, so it just talks about, okay. Seth said that the probability of picking a red marble is 1/2. Do you agree or disagree? All right, so 5 red marbles out of 10. So we have 5 out of 10. But he said it was 1/2. And that's because 5 is 1/2 of 10. So these are what's called equivalent fractions. Okay, so I would agree. Refer to the table in example 4. Which fraction best names the probability that the spinner will stop in sector 3? Okay, in example 4. Well, we assume it's this one that they're talking about, right? Here we got it, and I don't know looking at this exactly how many times, what the percentage here, but I can look here. 111 is very, very close to 1/6 of 60, right? So if we have 11 out of 60, okay, that's a very similar fraction. We're going to round it to 10 out of 60, which is an equivalent fraction to 1/6. Okay, so that's where I'm getting my math here from that, because it's asking us to kind of guess. We don't know for sure. So which fraction best names the probability? Okay, it's probably D again, 1/6. All right, that's your work. Go ahead and work on your written practice and have yourself a good day.